We're going to be talking about a concept called continuous versus discrete for this lesson. You can see these two graphs are different in the fact that this one consists of individual points and this one consists of a line that is unbroken right there, or a curve that is unbroken. The definition for continuous is that there are no breaks or gaps anywhere in the graph. So this is an example here of a continuous graph. From start to finish, there are no holes, no breaks, no gaps, no jumps. It is continuous through the entire graph. Discrete is kind of on the other end right here. Discrete means that the graph consists entirely of individual points. So you can see each of these points has space around it. It is not connected to any of the other points. Our entire graph consists only of individual points. Now some graphs might be neither of these. You could have an example where, say, we have some individual points over here, where we have a continuous portion over here, or maybe we have a section that's here and then it jumps up to there. In this case, if we had kind of a mixture of the two, we would say that it is neither. So we have three possibilities when we're talking about continuous without these, or discrete, or it might not fit either description. So let's talk about a couple of examples of some data. The first one that I want to deal with is the number of people that come into my classroom over a given time. So when a class starts, there are 0 students in my classroom. As time progresses, the students will increase. We'll get 1 student, 2 students, 3 students, 4 students, 5 students, and so forth. So as time passes, the number of students increases in my room, and it continues until all of the students are in my room. Now, this right here consists of individual points. This is a discrete graph. The people in my room is a discrete measurement. If I were to connect these and turn it into a continuous graph, this would cause an error in my measurement. This would be telling me that I have in-between values for the number of people in my room. For example, at some point, this blue line right here shows me that I had 1.9 people in my room. That doesn't happen. When we count the number of people, we are counting discrete values of 1, 2, 3, 4, 5. So we should not have these connecting points here. This is a discrete example. Let's take a look at these two. We've got two situations here with tables of values. Now these are individual points, but the question would be, do we have in-between values that would connect those and make them continuous, or are they separate points and should it be discrete? So taking a look at our inputs and outputs, we have bags for our inputs and the number of marbles that we have for our output. Now, when we're counting up marbles, we count 1, 2, 3, 4, just like with the people in my room. So this is an example of discrete data. We won't have any in-between values like 1.9 marbles. On the other hand, for this one, we have our input is years and the output is the height of a tree. Now, with the height of a tree and years, this is an example of a continuous graph. So we could actually go back to here and say time and then the height of a tree and create a graph that over time the tree grows, and we can measure it at individual points here. Now, if I left this as discrete, it would be saying that our tree jumps from one point to the next. Its height grows in steps, and that is not the case. With a tree, it continuously grows. It is going to cover all of the in-between values from here to here, here to here, here to here. Time is also the same way. We don't jump from one step to the next, from one time to the next. It continuously increases. So we should include all of the in-between values for this situation. So this is an example of continuous. Thank you.